I would like you guys to begin today's notes by actually drawing the outline of a periodic table, kind of like we did a few days ago. So imagine each line is a row on your notebook paper. 1, 2, 3, 4, 5, 6, 7. There we go. Doesn't have to be perfect or everything be evenly spaced. Kind of help you along. The D block has 10 columns. The P block has 6. The S block has 2. The F block has 14. I know that's gonna, you guys are looking like you're focusing hard on getting that done. I'll wait for you. We're going to refer to this diagram as we do our notes today. Okay? You're going to be drawing all over it. Ready? Okay. Here we go. Where's my highlighter? This is the P block. Highlight it. If you don't have a highlighter, circle it, do something to make it stand out. Did I say this is the P block? Yeah. Man, it is Friday. This is the S block. It is going to be groups 1 and 2. What is the maximum number of electrons that the S block can hold? 2. How many electrons, excuse me, wrong question. How many valence electrons would you expect there to be in column number 1? So in group 1, you have 1 valence electron. In group 2, how many valence electrons are there? 2. That's it. So the S block can have a maximum of 2 valence electrons. Let you guys get that written down. Here's the bonus question. except for hydrogen, group 1 is called what? The alkali metals. Okay. What are the group 2 metals called? Alkaline earth. Now, what part of the P block is technically part of the S block? What element would that be? Yeah, so shade that in as well if you can, or circle it to make it part of S. All right, once you know that, let's move on to the P block. The P block is going to be groups 13 through 15. How many valence electrons would an element have if it was found in group 13? 3 valence. How about group 14? I think we're starting to pick up a trend here. Group 15? All right, Alex, no more from you. How many in group 16? Oh, look, everyone else has voices. How many valence electrons in group 17? 7. Now, this next one, I'm going to warn all of you, and if you don't heed my warning, I'm going to call you out on this day, October 20th, to say, you remember? You remember when I told you this? Here, you might have no idea what I'm talking about, but you will here in a second. Group 18. How many valence electrons are there? With the exception of what? I cannot tell you how many times I've had students do this. You ready? This is wrong. I might say in the not too distant future, hey guys, for 1,000,000 points extra credit, do the electron dot structure of helium. You know what kids do? 1, 2, 3, 4, 5, 6, 7, 8. And I just go, oh, I told you on October 20th, 2023. How many valence electrons does helium actually have, everybody? 2. So don't ever let me catch you putting 8 valence on helium. It has 1, 2, because on the first energy level, you only need 2 electrons to be stable. So don't get careless when you're asked to do helium. All the other ones, neon, argon, krypton, xenon, radon, they have 8. Go for it. But helium only has 2. You have been warned. So I'm going to put this, put a little asterisk here. Asterisk. Helium has 2 valence electrons. Okay. Couple of little bonus questions here. What do you call group 17? They're called the halogens. The first 2 are gases. The second one is a liquid. The last 2 are solids. And what do you call the group 18 elements? Noble gases. The P block can hold a maximum of 6 electrons. Now, to go back up here, I had a couple of you text me on the side, and you were asking, how do I figure out how many valence electrons an element has? And I'm glad that you texted me. The answer to that is you simply combine the S and the P. So I'm going to write a few in here. You guys don't need to write these in here. I just want to see if you all, as a class, everybody can just identify how many valence are each one, okay? So you don't need to write this in there. I'm just going to write some random ones, okay? Barium. Look at where it's located. How many valence does it have? So what you do is you look at each column. See, I'm glad we're doing this. How many valence electrons does everything in the first column have? 1. How about the second column? 2. You skip over the D block, you move over to the P block. How many groups? 13. 3. 14. 4. 15. 5. 16. 6. 17. I see a trend. 18. Go ahead. With the exception of helium. So look, what group is barium in? What group? 2. So how many valence electrons does it have? That's it. That's all you got to do. Okay. How about oxygen? So what you do is you go 1, 2, 3, 4, 5. Boom. There it is. 6. Okay. How about boron? 3. How about polonium? See how easy this is? How about bromine? 7, right. How about neon? Very good. How about hydrogen? Good. How about nitrogen? 5. Carbon. 4. Fluorine. Not 6. 7. 13 has 3. 14 has 4. 15 has 5. 16 has 6. 17 has 7. 18 has 8, with the exception of helium. Okay. A couple more. Just, I'm not totally convinced yet. A few more, not just a couple, a few more. Potassium. 1. Arsenic. Where am I going to put it? Right, I think it's right there. Arsenic. 5. Gallium. 3. Calcium. 2. Krypton. 8. Selenium. 6. Germanium. 4. So all you have to do is look in the column. 1 has 1, 2 has 2. But then you got to skip the D block, go to the P block. 13 is 3, 14 is 4, 15 is 5, 16 is 6, 17 is 7. That's it. So if you were ever asked how many valence electrons there are, find it and then just count. But now that brings me up to something that might trip you up a little bit. The D block. Go and color that in however you want. I'm going to use pink. That's what we're doing next, Aiden. We're doing the D block now. This question was, how do you do something like copper in the D block? That's what I'm going to sort out for you all now. Okay. A few things about the D block. They contain transition metals. The D block is the largest block in the periodic table. It has groups 3 through 12. And again, this was on your vocab quiz. A group is a column. It can hold a max of 10 electrons. Notice I did not say valence. Now, here comes the key thing, what you're asking about, Aiden. With a few exceptions, Elements in the D block have 2 valence electrons. Now, I know that we always like to have the underdog story and the exception to the rule. Like the Bucks won all their playoff games on the road, and then they had the Super Bowl at home and they won it. And that's the exception to the rule. Lucky us. But don't glorify the exception. My mom used to do that. She smoked my whole life. Mom, smoked is going to kill you. I could get hit by a bus tomorrow. Right. My mom smoked since she was 5. Okay. That's the exception. If Connor was to walk across the road on Dale Mabry blindfolded during rush hour, makes it to the other side untouched, that doesn't mean everybody can do it. So I don't want you guys to glorify the exceptions. So don't get obsessed when I say a few exceptions, because there's a lot of elements in the D block. There's maybe 2 or 3 that are the exceptions. So don't get all obsessed with that. On this periodic table, what block, if you're going from left to right, what block comes before the D block? The S block. And the S block is completed by the time you get to the D block. Now, if you recall from the last unit, Aiden brought up copper. So let's do copper here for a second. I'm going to plug it in right here, if I can get my pen working. Now, if I ask you guys to write the electron configuration of copper, let's see if you remember a few things. It would go 1s2, 2s2, 2p6, 3s2, 3p6. Now, can you help me with this next row? I'm on the 4th row. What do I write first? 4s2, very good. Then what? 3d9, awesome. Now look at the very back. What number is higher, 4 or 3? Very good. That is the highest energy level, 4. And how many valence electrons does it have on that 4th level? 2, right there. So there are a couple exceptions, but remember that whenever you do the D block, the coefficient, which is this number here, that 3, it's always going to be 1 less than what the S and the P are. So, for example, guys, if S and P are 4, what's the D block? 3. If S and P are 7, what's the D block? 6. 7 is always 1 higher than 6, and that's what you use to figure out the valence electrons. So pretty much everything in the D block, I'm not going to highlight the exceptions today. Everything in the D block has 2 valence electrons. If I ask you guys to do, let's do mercury. Let's do it. Mercury is going to be right here. I want you all to help me out. Here's mercury. And I want to get to the very end, okay? So help me start. Come on, let's hear it. 1s2, 2s2, 2p6, 3s2, 3p6, keep going, 4s2. Now, take your time. 3d10, 4p6, very good. Skipping a line. Okay, 5s2, what's next? Not yet. You're not stupid, Alex, you're learning. 4d10, 5p6. All right, now we're on the road that Mercury's on. 6s2, 4f14, because that's plugs in right here. Then what? 5d10. Okay. What energy level appears to be the highest? You have gone through 1, 2, 3, 4, 5, 6. What's the highest? 6 is the highest. And how many electrons does it have on that 6th energy level? 2. So how many valence electrons does Mercury have? It has 2. So there are a few exceptions, but we're not going to glorify those. All the elements in the D block, with a few exceptions, have 2 valence electrons. Okay, so I don't care if you're doing gold, iron, copper, iridium, zirconium, cadmium, all those things. Mercury, they're going to have 2. Okay, are there any questions about that? Then let's do the last block. Okay, which one are we missing? We're missing the F block. Go ahead and color it in. I'm going to use purple. If you don't have purple, use a substitute. Do something different. Okay. F block. These contain the inner transition metals. They have a maximum of 14 electrons. Notice I did not say valence. There's 14 columns, so there's 14 electrons there. They have a filled s orbital. So if their s orbital is filled, what's the maximum number of valence electrons they have? 2. They have 2 valence electrons. We'll do a couple of those to explain this to you all. Okay. So if you go up here, hold on, plug in my computer. Okay. So if you go up here and let's say we're going to do number 71 right here. Lutetium. Lu. Let's do the noble gas configuration to save us some time. I don't know if you guys were paying attention when I told you this, but this block right here, the F block, it fits in right here. So focus on this. What noble gas would come before lutetium if this is all right there?
Xenon.
Right. Xenon comes before it. So let's start with xenon. Let's do the noble gas configuration for lutetium. How do we start the rest of the configuration? 6s2 is correct. Then what? 4f14. So I explained this in unit 3, but if you missed it on that day, you weren't paying attention. The D block is always 1 less than the S and the P. The F block is 2 less. And the F comes before D. So you would have S, 2s2, right here. 4f14. And then if I were to ask you to do, let's say lead, right here, PB, lead. After you did 4f14, you would come back here. What would this be? It would be the D block, but what's the principal energy level? This would be 5, D, 10, and then what? 6p, 2. So lutetium is going to be 4f14. But what came before 4f14? 6s2. What number is higher, 6 or 4? 6. So you know that the 6 energy level is the highest. And how many valence electrons does it have on that 6 energy level? 2. So all the F block, with a couple exceptions, I'm not going to glorify those, they have 2 valence electrons too. So to make your lives infinitely simpler, we're not going to glorify the exceptions. The D block and the F block have how many valence electrons for each element, with a couple exceptions? 2 of them. Good. Now to go back to make sure that all of you understand this, because again, several of you texted me, how do I find the number of valence electrons? You add, there's 2 ways you can do it. 2 ways. I don't care which way you use because they're both right. You can either add up, actually 3 ways. You can add up the electrons in the S and the P combined. So if I ask you to find the number of valence electrons in phosphorus, you would have to do 1, 2, 3, 4, 5. That's one way to do it. Just count from the left. 1, 2, skip the D block.
Here's some information.
3, 4, 5. Here's the second way to do it. Look at the column. How many valence electrons are there in group 1?
1.
Group 2?
2.
Group 13? 14, 15, 16, 17, 18, with the exception of helium. So I asked for phosphorus, it's group 15. How many valence are there? 5. How many valence are there in the entire D block with a couple exceptions? 2. How many valence electrons are there in the F block with a couple exceptions? 2. Nick, you following this? One last way, and then we'll call it a day. Just like I had you do on the test problems we just did. Let's say that I have a mystery element, okay? I give you that configuration. I don't know what element that is yet. We'll find out in a moment. Some of you may have already looked. How many valence electrons does that element have? And underline them. Well, first thing you should do is ask yourself, okay, what number is higher? 1, 2, 3, 4, 5, and that's it. What number is higher? 1, 2, 3, 4, 5. Easy. How many electrons are on that 5th energy level? 8. 1, 2, 3, 4, 5, 6, 7, 8. What element is that? Xenon. Right there. So you just need to find the highest principal energy level, then count the number of electrons on that level. Okay. All right. Are there any questions? I see Vernon has his hand up. Yes.
Earlier when you were like writing about that block of stuff, you said a maximum of 14 electrons. So, like the radium, for example, has 22 electrons.
That's no, a maximum of just 14 on that section. Because remember, this periodic table is a little weird. These two should be right there. So you got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So the F block has a maximum of 14 elements per row. That's what I mean by max of 14. Is there anything else, guys? Okay. Before you're out of here,